Hey guys, welcome back. We're going to start the next part, which is really kind of the last thing that we have new, which is inverse trig functions. So a very similar setup with how we set up trig functions. There's just a slight difference in how we solve the problems at the very end. But before we get into that, we need to first remember some of our algebraic properties and what an inverse operation is in the first place. So here we have algebraic identity properties. So if we remember, the additive identity is what we add to something in order for the identity to remain the same. So what do we add to A in order for it to remain the same? Well, the additive identity is 0, right? And then the multiplicative identity is what we multiply by in order for it to stay the same. So A times 1 would be still equal to A. And then the exponential identity is what we put something to the power of in order for it to remain the same. So anything to the first power, just like a multiplicative identity, is also 1. So anything to the first power is still is just going to be that anything. So then the next thing we have are the inverse properties. And the inverse properties are what we do in order to get to the identity properties, just to make things go away, for example. So if we have A and we want to get it to 0, which is going to be the additive identity, how do we undo a positive A in order to get it to 0? Well, we subtract A, right? Or we add an opposite A, in other words. So how do we undo 4 to get it to 0? Well, we subtract 4, right? So the additive inverse is subtraction, or it's adding the opposite, in other words. Then multiplicative inverse. So if we have anything times what is going to get it back to the multiplicative identity, which is 1. So that would be or A to the negative 1 power, or the reciprocal, or 1 divided by A. So in other words, multiplication is undone by division. Okay, so the same kind of idea, but if we have 2/3, how do we undo 2/3? Well, what we're actually doing here is multiplying by the reciprocal. Just like here we have 1 over A, we flip the order. Well, we're actually going to do the reciprocal of 2/3, which is the same thing as 3/2. Now, when we multiply 3/2, we're going to multiply across the top and across the bottom. So 2 times 3 is 6. And then 3 times 2 is also 6, and 6 divided by 6 is equal to 1. So that's why when we multiply by the reciprocal, it gets us back to 1. Then the exponential inverse is going to try to get the exponent to a 1. So if we have a squared, how do we undo a square? Well, we undo it with a square root, which is the same thing as the 1/2 power, because half of 2 is 1, right? Then if we have a cube, how do we undo a cube? Well, we do the cube root, which is the same thing as the 1/3 power. 1/3 of 3 is 1. Same thing with a fourth power, that would be the 1/4 power. That sounds like the same thing. And same thing with anything to the fifth power would be the 1/5 power of that, or the fifth root, which would undo that as well and get it back to the exponential identity, which would be 1. So let's put all this together. So our properties of equality are basically balancing an equation by doing the same operation to both sides. This actually has to do with our inverse operations, which will take it back to the identity property, which makes it go away, in other words. So kind of putting it all together. So if we have 2x squared plus 4 is equal to 36. This balancing beam tells us that at that time that expression is balanced, where the 2x plus 4 is going to be equal to the 34. So what I want to do is I want to take this plus 4 and I want to make it go to plus 0, because then it goes away, right? Which would be our additive identity. So we undo addition with subtraction, right? That's the inverse operation. So if I subtract 4 from one side, if I take 4 off of this side, now it's going to be too light, right? So it's not balanced anymore. So what I need to do is I need to take 4 off for the other side in order to make it balanced again. So if you take 4 off one side, you have to do the same thing to the other side, and that is called the subtraction property of equality. So if I subtract 4 from one side, I have to subtract it from the other side. And the reason we did that is now these two are going to add up to 0, right? Plus 4 minus 4 goes to 0, which is the additive identity, which is what we wanted in the first place. So what we're going to end up having on this side is 2x squared plus 0, right? Which is just 2x squared, is equal to 32. Now this is still balanced because we just subtracted from the same amount from both sides, so it's still balanced by the subtraction property of equality. So that was the first thing that we did. All right, now the next one is I have this 2x squared. I want to get rid of the 2. So how do we undo multiplication? Well, I'm going to divide both sides by 2, and that's going to be the division property of equality. So if I divide one side by cutting it in half, I have to cut the other side in half as well, which means x squared, oops, didn't mean to do that. Spoilers. So that means that x squared is going to be equal to 16. So those are still going to be balanced. And then we undo a square. We want to get that to the exponent of the first power. So we do the 1/2 power. So if I do the half power one side, I have to do the half power of the other side, which is the exponential property of equality. So basically square root both sides. And then we're left with the final equation, which is going to be that x is equal to the square root of 16, which is 4. So we're all done there. And that was just solving there. So x is equal to 4. If we plug it back in, the entire time these were always going to be equal to each other. We just did our properties of equality to get to the very end. So technically when we're solving with algebra, we're using identity properties, inverse operations in order to get it to the identity properties, and then properties of equality in order to remain balanced the entire time. So it's kind of putting all that together. What a good review. All right, so what are the inverse operations? So the inverse operation of addition would be subtraction, right? Those two undo each other. The inverse operation of multiplication is division. Subtraction is undone by addition, just like addition is undone by subtraction. They're inverse operations of each other. Square roots are undone by squaring. Division is undone by multiplication. Trig functions are undone by inverse trig functions, and that's what we're getting at today. Now inverse trig functions are just like a reciprocal to the -1 power. So let me go ahead and pull up my phone. So let me go ahead and pull up the calculator here for us. So if we have our trig functions sine, cosine, and tangent, the inverse trig functions, usually they're written right above it, are going to be sine to the -1, cosine to the -1, and tangent to the -1. So we're going to get those by clicking the f of x button here. And then that's going to show us the sine, inverse cosine, and tangent. Inverse tangent. So those are the reciprocals, in other words. So the trig functions are sine, cosine, tangent. The inverse trig functions are inverse or sine inverse, cosine inverse, and tangent inverse. So let's try our first example. All right, so on this one we have, our angle. Okay, normally when we're doing trig functions, they give us the angle. Like 30 degrees or 49 degrees or something like that. But in this case, the angle is actually what we're solving for. So if you notice, that's what's different about using an inverse trig function, is we're using inverse trig to be able to solve for the angles. So anyway, x is still going to be the angle that we're solving for, and then 2 is going to be the opposite leg, and 4 is the hypotenuse. So if you notice on this one, we're not using the adjacent side, so that means that we need a trig function that relates the opposite and the hypotenuse, which is going to be the sine function. Also, you'll see we can't use the cosine or the tangent because they involve the adjacent side, and we're not using the adjacent side. So we need to use the sine. And so we set up the equation exactly the same, because the sine ratio, the sine of the angle is equal to the opposite over the hypotenuse. So sine of x is going to be equal to the opposite over hypotenuse, which is 2 over 4. Now, what's different about this one is normally the x is either on the top or the bottom. If it's on the top, we'd multiply by 4. If it's on the bottom, we switch these two. What you don't do is do sine of 4. You don't switch the x and the 4, okay? The x is trapped inside the function of sine. And so we have to undo the function in order to get x out of sine. So we need to use an inverse sine in this case. So the sine inverse, we're going to take the sine inverse of the sine of x. If we take the sine inverse of one side, we have to take the inverse sine of the other side as well in order to keep it balanced. Just like squaring both sides to undo a square root, or multiplying both sides by 2 to undo a 1/2 or something like that. We do the inverse of sine to undo the sine function. So those two are going to undo each other. The sine inverse of sine is just going to be just the x. So they undo each other, leaving us with just the x. So x is equal to the inverse sine of 2 over 4, or we would write sine inverse of 2 over 4. We just write it backwards, in other words. All right, so I need to put this in the calculator, so I'm going to pull up my calculator here. So launch your scientific calculator from GeoGebra. And the sine, cosine, and tangent functions are here, but we want the inverse sine. So we have to go to the function of x button here, and then I'm going to do the inverse sine of 2 divided by 4. So I'm going to do 2 divided by 4. You can put that in as a fraction if you want, using the n over d button, or just 2 over 4 would be just fine there. All right, so that was equal to 30, and it should be 30, right? This is a 1, 2, and radical 3. So this length here would actually, if we solve for it, it would actually be 2 radical 3, because it's similar to the one that's shaped like this with side lengths of 1, 2, and radical 3, right? Those are similar. So if we're going from 1 to 2, then the 2 goes to 4, and then radical 3 goes to 2 rad 3. So which means this smallest angle here has to be 30 degrees, just like it is here. That has to be 30 degrees. And sure enough, it is 30 degrees. So let's do another example here, just make sure we know how to set it up. We're solving for the angle x again. So we have the opposite leg and the adjacent leg. So the trig function that relates the two legs are going to be tangent, opposite over adjacent. So we'll say tangent of x is going to be equal to 3 over 4. Now to undo the tangent function, because x is stuck on the inside of the tangent function, so we have to do the inverse tangent of tangent of x, and then we do the inverse tangent of the other side as well, just to keep it balanced. So the inverse tangent of tangent is just going to be x. So they undo each other just like a square undoes the square root, etc., etc. So we have x is equal to the tangent inverse of 3 over 4, and we're ready to put that in the calculator again. So I'm going to do the function button, tangent inverse, and then I'll go ahead and put this in as a fraction just because I can, and we'll do 3 over 4, which is going to give us an angle of 36.67 if we round, so 36.87, sorry, dyslexia. All right, one more example, then we're done. This one's a little tricky because our right angle is actually right here, which means this side on the bottom is our hypotenuse. So what we're doing here is the adjacent side, or the adjacent leg, and this is the opposite leg. So we're using tangent again. Tangent of x is equal to the opposite over adjacent, which is 8 over 8. This one actually should kind of look familiar. If these two sides are the same, it has to be an isosceles right triangle, so this angle has to be 45. But to solve it like we know before, to get x out of tangent, we do the inverse tangent. Do the inverse tangent of both sides. The inverse tangent of tangent is just the x, so they undo each other, leaving us with x is equal to the inverse tangent of 8. So I'm going to put that in the calculator. So do the function button to go to inverse tangent of 8 over 8, which is 1, but I'll do it as a fraction, not a big deal. So 8 over 8, which is 45 degrees. So yes, x is equal to 45 degrees. All right, so on number 1, we want to solve for the measurement of angle x. Now, if we look on this one, for angle x, we have the opposite leg, we have the adjacent leg, and we have the hypotenuse as well. So since we have all three of the sides of the triangle, we can actually use any one of our trig functions. And so we're going to set them up using all three of them to make sure we get the exact same value. So let's use the sine of x. So sine of our angle x is equal to the opposite over hypotenuse, which would be 12 over 13. The cosine would be the adjacent over hypotenuse, which is 5 over 13. And then the tangent is the opposite over the adjacent, which would be 12 over 5. So notice we had all the things that we needed to set them up with either one, any one of those. And then the next thing, to get x out of the sine function, we have to do the inverse sine function. So we do the inverse sine of both sides, which will leave us with x is equal to the sine inverse of 12 over 13. So I'm going to put that in the calculator real quick. So we're going to do, so go to function, so sine inverse of 12 divided by 13, which is going to give us 67.38. All right, so we get 67.38 degrees. Now if I do the same thing with the cosine of x, we would do, we have to get the x out of the cosine function, so we use the inverse cosine of 5 over 13, so we'll put that in the calculator. All right, and that gives me the exact same thing, right? So we get the exact same angle, and then we do the tangent inverse of 12 over 5. This is not a good time to have dyslexia and flip numbers because you'll get the wrong answer if you do that. All right, so function of tangent and then 12 divided by 5. Well, that's why you got the answer bank. All right, cool. So if you do something wrong, if you set it up wrong, or you flip numbers or something like that, you won't get the right answer. Just look at it again, see if you can see what you did wrong. You might have flipped the opposite or adjacent or set up the fraction backwards or something. But use your answer bank to figure out what you're doing wrong. All right, so that's it for number 1. When they give us all three sides, which is rare, we can use whatever trig function we want. Number 2, so this one's a little bit challenging because it's flipped upside down. So your hypotenuse is opposite of your longest side. The longest side's opposite the biggest angle, the right angle. Then with respect to x, we have the opposite angle over here and then the adjacent angle over here. Now on this one, you might recognize it's actually 30, 60, 90 because we have 1, 2, and radical 3. It's just 5 times the scale factor of 1, 2, radical 3. So this angle here is opposite of the medium angle, so this would be 60 degrees. Now, in order to set this up with one of our trig functions, because we have all three sides, we can use any one of the trig functions we want. So I use cosine, so that's going to be cosine of x is equal to the adjacent over hypotenuse, which is going to be 5 over 10. Then we undo the cosine function with the inverse cosine. So we're going to end up doing, you don't have to show that step of the inverse on each time, just set up the equation. So cosine of our angle is equal to the adjacent over the hypotenuse. And then we're going to put it in the calculator as the inverse cosine of 5 over 10. And that's going to undo the cosine function to give us out the angle. I'm going to go ahead and clear all this out because it's getting a little bit busy. All right, so I go to the function cosine of 1/2. You can do 0.5 if you want. You can also do it as 5 divided by 10. Doesn't really matter, which is 60. So yes, it is 60 degrees just like we knew. So cross it off on your answer bank as you go. That way you make sure that you're doing it right. All right, number 3, we're solving for the measure of the angle. So again, we're going to be using the inverse trig function. Which trig function are we using? Well, we have the opposite leg and the adjacent leg. The one that we don't have is the hypotenuse. So I can't use the sine function or the cosine function. The one that relates the opposite and the adjacent is the tangent function. So tangent of our angle x is equal to the opposite over adjacent, which is 3/10. Then again, we're going to do the inverse tangent of both sides, right? So inverse tangent of 3/10. All right, so that's equal to 16.70 if we round. So 16.70, that's going to be one of our answers, so we know we did it right. The next one we're going to do together is number 10. This one's a little bit challenging because you really have two triangles that you have to solve for. So the first one, if I want to solve for x, I need two sides. I've got the 45, but I don't know what w is, so I can't actually solve for x yet. So instead, I need to look at the triangle on the left. So since I have a side and an angle, I have enough information to solve for w first. So that's going to be my first step. With respect to our angle, we have the hypotenuse, which is 30 degrees. We also have the opposite side, which is w. So if I'm using the opposite and the hypotenuse, that's going to be the sine function. So sine of our angle 44 is going to be equal to w over 30. And then we're not solving for an angle this time, we're solving for w. So I got to get rid of the 30. So it's on the bottom, division, so we multiply both sides by 30. So I'm going to put in the calculator 30 sine of 44. So we're going to have 30 sine of 44, which is 20.84. So w is equal to 20.84. You can write it here if you want. That's also going to be one of your answers on the side, which we can cross that out. All right, now that I have this side here, I can solve for the missing angle. So this is now going to be the adjacent side. Okay, the 20.84 is the adjacent side, and then the 45 is going to be the hypotenuse. So I want to write this as a trig function using the adjacent and the hypotenuse, which is cosine. So it's going to be the cosine of x is equal to 20.84 divided by 45. So on this one, again, we're solving for the x, which is the angle. So we're going to have to undo the cosine function with inverse cosine. So we take the cosine inverse of both sides, right? Those two undo each other, leaving us with just x is equal to the inverse cosine of 20.84 over 45. So that's what I'm going to put in the calculator. So cosine inverse, let me just put it in as a fraction so it's a little bit clearer. So 20.84 divided by 45, which is going to be 62.4. So this angle here is 62.4, which should be, 62.41, which will be our angle there. So on number 11, I can solve for w or y first. We'll solve w first. I've got the angle and an opposite side here. Then this is the adjacent side, so I'm using the tangent function, if you remember. So tangent of 70 degrees is equal to 16 divided by w. Then when w is on the bottom, if you remember, we have our shortcut, right? We can just switch the order of those two. You don't actually have to rewrite it again if you don't want to. We're just going to put it right in the calculator just like that. So I'm going to put it in as 16 divided by, let me do the fraction button first. So 16 divided by tangent of 70, which is 5.82. So w is equal to 5.82, and we can cross that off on our answer bank as well, so we make sure we did it right. All right, then the next one I want to solve for y. So y is this length here. We've got our angle of 41 and the opposite side. So we have the opposite and adjacent, so I'm using tangent again. So tangent of 41 is equal to 16 divided by y. We switch the order of those two because y is on the bottom. Okay, so 16 divided by tangent 41 this time. Put it in as a fraction as 16 divided by tangent 41, which is 18.41. So y is 18.41. And again, we can cross it off here so we know we did it right. Then the last one is to solve for x. So if the whole thing on the bottom is 18.41 and this side is 5.84, all we have to do is subtract those two, put it in the calculator, you'll get 12.59, and we subtract those two. So we know we did that right. All right, number 12, it says Jed is building a roof for his shed. The highest point on the roof will be 3 feet higher than the top of the shed. So the highest point on the roof is 3 feet higher than the top of the shed. So I kind of drew that out for you. The slanted roof will be 7 feet long, so that's the slant height here, which is going to be a length along the side. What's the measurement of the angle formed by the top of the shed and the slanted roof? So basically that's going to be what's the incline or the slope of the roof. Well, we've got the opposite leg and the hypotenuse, so we're using the sine function. So sine of x is equal to 3 over 7. Then we undo the sine function with the inverse sine. So I'm going to put this in the calculator as sine inverse of 3 divided by 11, or sorry, 3 divided by 7, which is 25.38 if we round. So 25.38, that's one of our answers, so we know we did it right. Number 21, an architect includes a wheelchair ramp in her plans for the entrance to her grandparents' home. She wants the angle of the ramp to make with the level ground to measure 4 degrees. If the height of the porch is 4 feet, will a 50-foot base of the ramp work? So if we have a 4-foot high porch and then a 50-foot length of the base, is that going to be long enough in order to make the angle no steeper than 4 degrees? And so this is actually kind of a good problem. If we know, like for instance, code says that we can only have a 4-degree incline for wheelchair accessible ramps for ADA compliance or something like that, then we can actually figure out exactly how long it needs to be in order to make it work. So let's just guess and see if 50 feet will work. So we've got the opposite and the adjacent, so we're using the tangent function. It would be 4 over 50, and then we're undoing a tangent function to get the x out. So just like we did before, we take the tangent inverse of both sides. That's going to inverse tangent undoes a tangent function, so we have the inverse tangent of 4 over 50, and we can put that in the calculator. Which is going to be 4.57 degrees. So is it going to work? No, it's not going to work because it's slightly over 4 degrees, so it's not to code. So then the next question we would have is, what angle does this have to be? If this has to be 4 degrees, then how far out does this base have to be? We can't change the height of the porch, we can't lower the porch, but we can extend the ramp further out, which is what we would have to do, right, in order to lower the slope. So how much further out would we have to extend it in order to yield a 4-degree incline? So it was actually a very reasonable question to have. This is very realistic, and so we're still using the tangent function in this case, but now it's tangent of 4 degrees. We actually know the angle that we have to have is equal to 4 over x. When x is on the bottom, we use our shortcut. If you remember, we just switch the order of those two, so I can put it in the calculator just like that. So 4 divided by the tangent of 4, kind of cool. So 4 divided by tangent 4. Okay, so it has to be 57.2. So we were 7.2 feet too short. So just need to extend this out 7.4 feet, and then it'll be within ADA compliance. So probably go a little bit further than that so that we're not cutting it that close. All right, so if you have any questions on the homework, make sure that you ask. I think trig is going pretty smooth. I haven't had a lot of people have questions on it, which is wonderful. Inverse trig should be really simple as well. We're just undoing the trig functions now. So we have one more new topic, which will be angles of elevation and depression. It's pretty simple. There's some cool applications of trig and examples for review that we'll do as well with like indirect measurement. And we're even going to be doing a lot of trig when we go back in person with 2 games that we're going to do. And also at the end of school, at the end of the year, we'll go outside and we'll use some trig functions with some indirect measurement. With mirrors and shadows and inclinometers and apps on our phones and stuff like that. So got a lot of cool stuff for you to do. Trig is one of my favorite units. Right triangles in general is one of my favorite units. So got some cool stuff for you. Hope you guys are enjoying it. If you have any questions, make sure you let me know. And I'll see you guys later. Bye.